Good morning students, welcome to this session. I am Mohammad Maaz Rehan, working as Assistant Professor in the Department of Mechanical Engineering, MIT Mysore. In this session, we shall discuss about traveling salesman problems. So this is one of the biggest applications of operations research. In the previous lectures, we discussed about assignment problems. Again, under assignment, we discussed about balanced assignment problem, unbalanced assignment problem, maximization in assignment problem. So here in this session, we shall discuss about traveling salesman problem. So before proceeding with the problem, we shall understand what is traveling salesman problem, why we need to study traveling salesman problem. The objective of traveling salesman problem is to reduce the overall cost or the overall travel distance. I'll take up an example here. Say city A, city B, city C and city D. Now a person wants to travel to different cities. Say he is starting from city A, he can travel to city B, or he can travel to city C, or he can travel to city D. So we find different paths here. So the main objective in traveling salesman problem is to reduce the overall cost or overall travel distance. Okay, so here the one thing you need to consider here, if he is traveling from A, again he has to come back to the same city. Now we shall take one example under this traveling salesman problem. So here we have a salesman has to visit 5 cities A, B, C, D and E. The distance between any 2 cities are given in the table below. The salesman starts from A and has to come back to A after visiting all other cities in cycle. Which route he has to select so that the total distance travelled by him is minimum. Okay, so this is the problem. So here we have 5 different cities. City A, City B, City C, City D and City E. Okay, so and here 4, 7, 3, 4, this represents the travel distance. So it might be a travel distance or it might be cost. But in this given problem, they have given us a travel distance. Okay, so we shall proceed how to solve this type of problems. So here you need to understand here from A to A, or from B to B, or from C to C, or from D to D, and from E to E. So it sounds meaningless. So we have to introduce one term called infinity at these locations. Okay. So step number 1. So to solve the traveling salesman problem, so we proceed with the same Hungarian algorithm. So how we need to solve this? Okay. So step number 1. We need to check whether the given problem is square matrix or not. To check the given problem is a square matrix. Okay. Now, anyways, it is a square matrix. So we have, it is 5 cross 5 matrix, correct? Okay. So now I will just redraw the same table. 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. Okay. So here I have different cities A, B, C, D and E. A, B, C, D and E. Okay. So here we have 4, 7, 3, 4, 4, 6, 3, 4, 7, 6, 7, 5, 3, 3, 7, 7, 4, 4, 5, 7 and okay. So here in this given problem, they have just indicated as dash, right? So we shall introduce one term called infinity. Okay? Why we are going to introduce this infinity? Why? Because a person can't travel to same city, right? I mean to say that, so from A to A it is meaningless. From B to B is meaningless, right? So similarly, in any of the assignment problems, if you come across this dash, so it is nothing but restricted or prohibited assignment. Okay, so at that time you have to replace with infinity. Fine. So I hope this step is clear. So this step is, you have to check whether it is a square matrix. Yes, it is a square matrix, and we have introduced infinity. So that is nothing but restricted or prohibited regions. Okay. So we shall move on to the next step. That is step number 2. So step number 2 is row minimization. So in row minimization, this row, the least element is 3. So we need to subtract 3 from this entire row. Okay. So 4 minus 3, that gives 1. 7 minus 3 gives 4. 3 minus 3, that gives 0. 4 minus 3, that gives 1. In row B, the least element is 3. So it is 4 minus 3 is 1. 6 minus 3 is 3. 3 minus 3 is 0. 4 minus 3 is 1. In row C, the least element is 5. So 7 minus 5, that gives 2. 6 minus 5, that gives 1. 7 minus 5, that gives 2. 5 minus 5, that gives 0. In row D, the least is 3. So it is 0, 0, 4 and 4. Again E, here it is 4. So it is 0, 0, 1 and 3. Okay, this is row minimization. So we shall proceed for the next further steps, that is column minimization. So here we have 5 columns, 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. Okay, we have different cities, A, B, C, D and E. A, B, C, D and E. Right? So here we have infinity, 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 infinity and infinity. Okay. In column A, the least is 0, so it remains as it is. That is 1, 2, 0 and 0. In row B, least is 0, it remains same, 1, 1, 0 and 0. In column C, the least is 1, so this becomes 3, 2, 3 and 0. In D, it remains same, that is 0, 0, 2 and 3. In E, it is 0, least is 0, so it is 1, 1, 0 and 4. Okay, that is step number 3. Okay, so we shall proceed further. Step number 4. So what is step number 4? Step number 4 is draw minimum number of lines that covers all zeros, correct? So I'll just draw the same matrix, 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. Okay, we have different cities here, A, B, C, D and E. A, B, C, D and E. Okay, here I have infinity, 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 infinity and infinity. So 1, 3, 0, 1, 1, 2, 0, 1, 2, 1, 2, 0, 0, 0, 3 and 4. Here it is 0, 0, 0 and 3. Okay. So now here we need to draw the minimum number of lines that covers all zeros. So by seeing this matrix, we can say this, there are 3 zeros here. So I'll strike off this row, and again here I have 2 zeros. I'll strike off this row, and again here I have 2 zeros. I'll strike off this row, and here I have 1 zero. I'll strike off this row. Okay, so what is the next step? So here we need to check how many number of lines that we have drawn in order to cover the all zeros. Here we have drawn only 1, 2, 3, 4. Okay, we have drawn 4 lines, and the order of matrix is 5 cross 5, means to say that n, capital N is not equal to small n. Capital N is nothing but number of lines that have drawn in order to cover entire zeros. Small n is order of square lines that covers all zeros, and small n order of square matrix. If n is not equal to small n, then we need to, what we have to do, if capital N is not equal to small n, we can't proceed with the assignment part. So what we have to do, we have to check the elements which are uncovered. So here in this, the least is 1. So we have to subtract 1 from this uncovered elements, and at this intersection points we need to add 1. Okay, so I'll just write the matrix here. 1, 2, 3, 4 and 5. Here it is 1, 2, 3, 4 and 5. Correct? So here it is A, B, C, D and E. Here it is A, B, C, D and E. Correct? So anyways, at intersection of infinity, if I add any number, it remains infinity as well. So here the least is 1, so I will subtract 1 from this uncovered elements. So 1 minus 1, that gives 0, 3 minus 1 gives 2, 1 minus 1 gives 0, 2 minus 1 that gives 1, 1 minus 2 minus 1 that gives 1, 1 minus 1 is 0. So here I have 0, 0, 2, 0, 1, 1. Now here we have an intersection point, right? So it is 4 plus 1, that gives 5. Here I have an intersection point, that is infinity. So infinity plus 1 is infinity. So here also infinity plus 1 is infinity, and here we need to add 1 more, that is 3 plus 1, that gives 4. Correct? So the remaining matrix, it remains as it is. Okay, I hope this step is clear. Correct? So next we shall proceed. So what we have to do is next step. So we have to check, we have to draw the minimum number of lines that covers entire zeros. Correct? So now we shall draw the minimum number of lines that covers entire zeros. So here we have how many? 3 zeros. And strike off this. Here I have 2 zeros. Here we have 2 zeros, strike off this. Again here we have 2 zeros, strike off this. Here also we have 2 zeros, strike off this. So now obviously we have drawn 5 lines here, 1, 2, 3, 4, 5. So now capital N, which is equal to small n. So capital N is number of lines which we have which we have drawn in order to strike off all zeros, and small n is order of square matrix. So once capital N is equal to small n, we shall proceed for assignment part. Okay. So I will proceed with next step. So step 5 is assignment. Right? Assignment. So I will draw this. Same 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. Okay. Now proceeding with the assignment to suggest the best route. Okay, so in city A you have two zeros here. So from city A you can travel to B or you can travel to D. Okay, so we have different alternatives now here. So first from city A, so if I go to city B, you need to strike off the zeros that are in column. Okay, so why? Because you have to visit only city B at once. Okay, say I can't strike off this. Why? Because you can go to D city. Okay, so now you have traveled from A to B. So again come down to B. Okay, in B you can't assign at A. Why? Because you have already started from city A. Okay, so this is ruled out. So you can go to D, city D, and you strike off this zero. Okay, in this column. Okay, now you have come to city D, right? So from this city D, you come here. So you can't go to city A. Okay, next least is you have 3, right? So you have not visited city C. So you can assign this 3 and you strike off this 0. Okay, now you are in city C. Okay, go back to city C. Next, under this in city C, from city C you can go to city E. Okay, you don't have any zeros here. Again from E you have to come back to city J. Okay, this is what you have to do it in traveling salesman problem. So I'll just write the route. Okay, so how we have traveled? We have traveled. This is one alternative. So I'll call this as alternative 1. Okay, from alternative 1. Now in alternative 1 we have different route and we have different penalty, right? Okay, so we have started with here, right? A to B, right? So I can write, I have started with A to B, the penalty is 0, correct? Again from B, I have went to city D and the penalty is 0, correct? Again from D, I have moved to city C. The penalty is 3, correct? Again from C, I have moved to city E. The penalty is 0. Again, finally, from city E, I have moved to city A. The penalty is 0, correct? Now, if I add all this, the penalty will be 3. Okay, so I have started with city A and I have ended with city A, correct? So now this is penalty. In this case, in alternative 1, I got penalty as 3. Okay, I need to proceed for the further alternatives. I need to check which is having the least penalty. Okay, that is the best route we can suggest. Okay, I will write the alternative 2. Yes, now proceeding with the alternative 2, we shall. In the previous alternative, we have assigned to city B, like from city A we have traveled to city B. Now in this alternative, from city A we shall travel to city D. So first if I travel to city D, in that particular column I have 0, I'll strike off this. Okay. Next from D, I can't go to 1, I can't go to city A, I can go to city B, right? So what I'll do, I'll go to city B and I'll strike off all these zeros in this column. Okay. Now from city B, I can't go to city A, and here I can go to city C or I can go to city E. Why? Because the least is 1, right? I mean here we can't go at city A, we can go to city C or we can go to city E, correct? So say if I assign to C, I'll strike off this 0, correct? So now I am in city C. Again from city C, I can go to city E. Okay. So yes, again from E, I can go to city A, right? So that completes the route, correct? Now I will write here. Here you just need to observe here. Here you can go to city C or city E, correct? So anyways the penalty will be 1, correct? So here I will write the route as well as the penalty. So I will write the route and penalty, correct? So how we started? From city A we started to B. The penalty was 0, correct? Again from D we went to city B, the penalty was 0, correct? Again from B we went to city C. You have to observe here, you can go to city C or you can go to city E, correct? City C, the penalty was 1. Again from C we have went to city E, the penalty is 0. Again from E we went to city A, the penalty is 0. If you add this, we will get the penalty as 1, okay? Here. So comparing this alternative 1 with alternative 2, the penalty in this alternative 2 is 1, right? So in alternative 1 we got it as 3, means to say that alternative 2 is the best route, okay? So anyways we started from city A and we ended with city A, correct? So this completes the best route by comparing both alternatives. So best route is from A to D, D to B, B to C, C to E and E to A. I can write like this. Best route is A to D, A to D, D to B and again B to C and C to E and E to A. So this is the best route we can suggest for the salesman. So that completes the problem. Thank you for watching.